So now, because these genes are always transmitted together during the inheritance, what happens is that in lineage, we shall not get the dihybrid ratio of 9 to 3 to 3 to 1. So that ratio will not be there. And that is one of the reasons why we say lineage is one of the conditions that does not obey the principles of Mendel, or that one makes it to be called an exceptional to Mendelian inheritance, because it doesn't obey the Mendel's principles of inheritance. And I can say that because linked genes are always or are normally transmitted together. Because linked genes are normally transmitted together, they do not. Because linked genes are normally transmitted together, because they are normally transmitted together. In the F2 generation, the dihybrid ratio is never achieved. Dihybrid ratio is never achieved. This means that there is no independent assortment. There is no independent assortment of genes. No independent assortment of genes. So now, whenever there is lineage, what happens is that the genes do not assort independently, or there is no rearrangement of alleles to form new allele combinations, what we call independent assortment. It is never there whenever there is lineage. And so because of that, what happens is that the dihybrid ratio of 9 to 3 to 3 to 1 is never achieved, or is never realized. That's why we have said, because linked genes are normally transmitted together in the F2 generation, the dihybrid ratio, of course, you know that this ratio, dihybrid ratio of 9, dihybrid ratio, of course, that is 9 to 3 to 3 to 1 is never achieved. So that is it. So the dihybrid ratio here is never achieved. So this is due to absence of independent assortment of the genes. So members, next will be a cross-evolving lineage. So another time we will be looking at that cross showing lineage where there is no independent assortment of genes.